Hello, Sarah. How are you doing? Hi, everyone. How are you?
Paul, not Sarah, Paul. My daughter
Oh,
did.
hi, Paul.
My
I saw
daughter did
Sarah.
something to the
Okay.
computers, and even my computer at Moreno Valley High School. When I do a Zoom call, it puts her name on it. I have no idea how she did that.
You can change it on the view side, on the Zoom settings. You can probably change the name. Okay. And Paul, I will get in touch with you regarding summer if you want class. So we'll talk.
I don't know if I'm going to be able to do a summer class. I have to go to Virginia. There's some work being done on the house there, and I have to be there for that. And I don't actually have a good internet connection over there.
No, not a problem. So we can talk about the fall too, because I'm doing summer and fall schedule this week. So
Okay.
I'll email you, okay?
Okay.
All right. How's everyone doing? I hope everyone's doing okay. Okay. Check out your lab for today. We are going to do Fibonacci sequence. So let me get my editor up real quick too. We don't have too long of a lab today, so we want to kind of pace ourselves and understand a little bit more on the problem. So if you wanted to go to lab 6 and download, so let me share screen here. You should be able to find the screenshot that I put up there and make sure we download this document. Okay. Okay, so 6 o'clock, I'll go ahead and get started. If you have any questions, please unmute or type in the chat. So today we are going to do assembly Fibonacci sequence. This is a common group of numbers that we normally see in computer science, starting with CIS11. We do some of that in C++. If you had me, you probably are familiar with Fibonacci. But if you haven't worked with Fibonacci, you would often find Fibonacci in our natural things like sunflower. You would see the pattern of Fibonacci. Or when you're looking at a shell, like a seashell, you would see Fibonacci. Or even a pineapple have some pattern on the outside that look like Fibonacci. So you would see Fibonacci sequence in nature, in art, in science. And for computer science, this is often a sequence that we select because it's really to apply recursion or iteration when we program Fibonacci. Fibonacci is used in a lot of application. So just to give you a little bit of background, right? Fibonacci sequence it leads to golden ratio, is what you would see. And basically when you're looking at these numbers, they would have some type of pattern, right? For example, you would take the 2 prior numbers and add them together to get to the next. So the equation would be carried starting at a certain location of the index in that container. So in Fibonacci, this is really derived from the mathematician Leonardo of Pisa, and it was introduced to the Western world, but the original idea actually came from India. Now, computer algorithm uses Fibonacci, as you can see the highlight that I put in search technique. So there are many ways that we can implement search algorithm for different purposes. And when you're using your crawler, like on your search engine, it is an algorithm that's implemented. So Fibonacci is used for that. It also can be used for heap data structure. It can be used for graph, for parallel and distributed systems. So there are a lot of application in Fibonacci, and sometimes you might get an interview question when you apply for a development job to really solve problems that would contain Fibonacci. So here, what we can see is I put a link for like a TED Talk video where a teacher talks about how Fibonacci is a magical sequence. So if you have time, you can take a look at that. Now, when you look at Fibonacci, some of the sequence would start with, it seeds at 0. That means it begins at 0. But today we are going to seed it as 1. So the first value here, f of 1, is going to be 1. And the next value is going to also be 1. Okay, so those are going to be your starting point. So this is going to be initialized, and it must be, these must be 1s in our sequence. After that, we would take the two values, f of 1 and f of 2, and we add them together, okay, is what you see here, where you would have a 2, okay? And then after that, we would take f of 2 plus f of 3, then we would have a 3, f of 2, f of 3 plus, and so on. So we would continue the sequence by adding the two prior values. So this is why you can use recursion, in that it will build out the next result based on the two prior values. So we would start with the seed with 1 and 1, you get a 2, and so on. Now in recursion, what will happen is when you get further down on the sequence, that will take a little bit of time as it has to revert back to the prior location in the memory to retrieve, right, the two prior values in order to derive the next one, the next number. So we have to take a look at how we would approach Fibonacci. So here the equation would be that you would have f of n is going to be equal to f of n minus 1 plus f of n minus 2, where we would start with f of 1 is 1 and f of 2 is 1. Okay. Now in some sequence, like I said, you might seed at 0 and 1, but it doesn't really make a huge impact, for, you know, because it's still going to be the same value as you would do 0 plus 1, you get a 1, 1 plus 1, you get a 2, and so on. Okay. So we want to keep in mind this equation because that's going to apply in our algorithm for LC-3. So the problem statement is given here. We want to write an LC-3 program that computes f of n for the nth Fibonacci number. That could be 100, 1,000, whatever, right? So it's just an nth value. We want to find the largest f of n so that way it doesn't overflow. So here in this, starting with this lab, you are going to control overflow. So we don't want to exceed a certain value because that will require, right, additional allocation of memory. And so therefore we want to find the small n is going to be the large or the capital N, right, where we would represent n as the capital N. So we want to find the f of n as the largest value. So there's a distinguish between the n lowercase and the n uppercase. And the n uppercase is going to represent the location on the sequence, right, of a value that would be the largest in the sequence. Now your input will be n. And that's going to be at location 3100. Your output is going to be f of small n, that will be at 3101. So when you check your value on your simulator, this is where you're going to go. And this is what we're going to fill, okay? And then the uppercase N, the large N, is going to be at 3102. And F of the large N is going to be at 3103. So we would start with the example here, and it tells you that if we're looking at the number 6 in the sequence, because if we keep taking the two prior numbers, if we would get to 6 and 8. So the 6, which is the N, okay, the small N, that's gonna be at 3100. So that's when you use your simulator, that's what you would see. And then, so that means that F of 6 is gonna be 8, which is at 3101. Okay. And then for the actual value, that's going to be represented as your big N, or the actual value of the location is going to be the big N, and F of big N is going to be 3103. So what we want is we want to put this into the pseudocode to solve the problem. So here, based on the lab manual, this is what they give us. Okay. Now, in Fibonacci, we don't start at the index 0 on that container, okay? We actually start, so if you, I'm gonna come back to the first page real quick. We don't start here, okay? The addition, actually, the result from the addition happens in the third index, okay, or when we say 0, 1, 2, so N is 2, then that's when it's gonna take effect. Okay, so we're gonna do the addition, and the result of the addition is gonna be stored in this index and all the subsequent index after that when we will take the two prior numbers. So this is why we would have the condition that we need to apply. So you have to keep in mind of this because we have to make sure that this is applied with your branch. So we would say if N is less than or equal to 2, then, right, your F is going to be 1. Okay. So we have to, that's going to be the start. And in C++, you see this as well, right? If you have a Fibonacci function, you want to include the if statement in that function saying that if, right, if it is 2 for the location of that sequence is 2, then your F is going to be 1, okay? Because we have to seed it. Else, we are going to use, and this uses dynamic memory allocation. So we are going to use a variable to be able to store those values and then add them out. Okay. So we would have the A, which is our seed, the first value in the sequence. B is our second value in the sequence. So you're going to have F of N minus 1 and F of N minus 2. Those are going to be added to get to the next one. Okay, so in the else, that's what we need to start is we need to initialize the variable A and the variable B to be 1 and 1, and those are our starting point. Okay, then after that, we're going to loop because it's going to start storing the result of the addition after those values. So we're going to start with the index, the third index, as I mentioned previously. And we're going to go all the way to N. Okay, so we're going to do the 4. And we want to represent F is going to be equal to A plus B or B plus A, which is F of N is F of N minus 1 plus F of N minus 2. Take the two prior numbers and add it. And so therefore, we're going to loop it until it reaches the N value. And so in order to dynamically use the memory location, we want to reassign the A and the B. So the B is going to be A and the F is going to be B. Okay, so this is what we need to implement in our program. Now, how do we handle overflow? So what we want to do is we want to implement the for loop like what we've seen here, but we need to check and make sure that F, when it becomes negative, because we're using word size, right? Bit 16 is going to become 1. Okay, so we have to make sure that we branch and look for negative. So the caution is that upon the exit of the loop, F does not have the value of f of n. To really obtain this, you have to modify your program to include this. Okay, so you have to also add this so that way it's going to transition the F, because the F is no longer going to be, because when you look at this, right, F is now B, so we can't represent f of n as F here. So what we have to do is we have to implement this, okay, to control overflow. So as we see, A is 1 and B is 1, right? This is your loop index. We are going to repeat for F is B plus A, which is our equation, but we have to nest in another condition. If F is less than 0, because it cannot be negative, right? Your big N is going to be the index value. Okay, then it's going to exit the loop. And then again, we use dynamic allocation. So we are going to reassign the value. So B is going to be A. As when you're looking at the sequence, you're going to move right? So eventually it's going to take the A and it's going to move it to the next one. So the B is going to become A and the F is going to become B as you proceed in the sequence, if you can visualize that. Okay. And as we proceed in the sequence, our index is going to be index plus 1 because it's the next value up in that group of numbers. So your I plus 1 is going to be the index. Okay. So that is already given to us. So this is why we can implement what is suggested here in our LC-3 program. So based on that, we want to create the program. So I had screenshotted where you would be able to see it on the lab page, but let me open up my editor here. Any question before we start looking at our code? Okay, so like all program in LC3, we are going to originate at hex 3000. That's where our program is going to begin. That's going to be your first instruction line. So some of the things that you have to set up when you're looking at that problem statement, okay, let's come back, and we talked about this week, is that we are going to use this. So those are going to be your label. This is going to be your label, right? And anything that's part of the pseudocode that you need to handle as a label. And also there's some branches, so we have to fill some of the label, right? So these are your fills. So we want to make sure that we have that in mind. Okay. So first, we are going to load the small n to register 1. Right? That's part of the problem statement. Okay. And so we are going to load that to register 1. We are going to clear register 2 or initialize it to 0. And here is where we're going to start with the n is equal to 1. Okay. So what am I working on now? If you look at that part, this is what we're doing right now. This first 2 line, right? We have to get it to where it would be implemented this part. So we are going to get 1 to register 2. So we are going to add the decimal 1 to register 2 and store it onto register 2. Okay. And for the register 2, what we want is we are going to take the 1 and we're going to subtract or add -3 to it to get to -2. Now, why am I doing this part is when you look at this, right, we have to check to see if if n is less than or equal to 2. So we have to subtract the 2. Okay. Now, you don't have to do it this way. You can do an add with the 2's complement, but I wanted to kind of visualize it in the decimal. So this is how I use as the approach. So eventually what I'm doing is I'm going to subtract. So here I have the 1 initialized, then I'm going to add a -3 to it. So I'm going to have a -2 at register 2. Okay. And I'm going to take that register 2 and I'm going to add it with the register 1, which is n. Okay. And store it back to register 2 so I can branch. So what am I doing? I am working on this part right here. So in order to compare for less than and equal to, you subtract the 2, and that's what I did. Okay. And I need to represent the n. So for that part, okay, it's going to go and check what's in register 2 for the branch. Okay. And I need to branch to positive. So BRP pos. Then after that, I clear register 4 or initialize it to 0. And then I'm going to go ahead and add the 1 to register 4 because I'm going to get ready, right, to put the 1 to the F and check for the if. Okay. So what does that mean? This is the piece that I'm working on now. So as we talked about this week, when you look at your pseudocode, you're going to break it up into smaller chunks so you can handle it in assembly. So right now, I'm trying to get F to be 1, which is at register 4. And then I'll just store that out. Okay. So here I put F onto register 4, which is 1. So I added the 1 there, right? I haven't loaded the label yet because it's going to change based on the F value anyway. So after that, I'm going to store register 2. Where we left it was register 2, hold the subtraction to check, right? So register 2 is going to be my F of the small n, F of n. So store that to the label F of n. Then I'm going to branch to do an unconditional branch to skip. And we'll talk about the skip section when we get to it. Okay. But earlier I have a positive section, the label. So I have to start defining what that is. Okay. Since I previously used register 2, I need to clear it because otherwise it's going to keep holding the value that it previously used. So here I clear register 2 or initialize it back to 0. Then now I'm going to set up my A and my B. Okay, so again, sorry for the flipping back and forth, but now I'm working on this section because I took care of the if statement already. Okay, so now I'm going to do the else right here. Okay, so now what I'm going to do is I'm going to take register 2 and I'm going to add a 1 to it because it needs to represent my A is 1. Okay, this part. Then I'm going to clear register 3 because that's going to be my B. And again, I'm going to add the 1 to register 3 and put it on register 3. So register 3 has a 1 and B is 1. Okay, any questions so far? Okay, so now what I'm going to do is I'm going to represent the n-2 because if you're looking at how you would move, right, in the sequence, we have to take our current position, which is n, and if we need to move it to 2 places to the left, we have to subtract a 2. Okay, so this is why we're going to add a -2 to register 5, and we're going to take register 1. And so what is in register 1? That's your n. So we're going to take n-2 and put it on register 5. Okay, so that equation that you see, we have to piece it into smaller chunks, and then we need to represent that into assembly. Okay, any question with this? Okay, so that will be the positive section, right? And what I'm doing here is I'm addressing this part right here. Then I have to put F is equal to B plus A based on what they gave us for the pseudocode. So earlier we have the F in R4. So this is why it's so important that you track your register. So here we had F in R4. So in that, we're going to bring it down, and I have a label called for fab, right? So that's going to be here. And I'm going to add register 2. So what was in register 2? Well, where we left it, that was A, right? And I'm going to add it with the B, which is register 3, and then put the result in F, which is in register 4. So that's what you see here. Now we have to do the reassignment, because as we move in the sequence, the A is going to become the B. So we are going to do the add for copy. So we need to copy things over from register to register. So this part, basically you're just copying, right? Register 3 to register 2. So it's going to become A is B. Okay. So it's a little tricky, but when you look at that, if you see what value is in each of the register and how you use it, you can quickly move through the equation. Okay, so here at this part, I have A is equal to B. So coming back here, right, we hit this, we got F is B plus A, and then now we have this. So the next part is going to take register 3, copy it, or register 4, copy it to register 3. So that's easy. Okay, that's exactly what's here. Take F, which is in register 4, and copy it by adding the 0 to register 3. And then now, because if you recall, right, we did the n-2 here. So our n is in R5. So we're going to take n minus the 1, which is we add the negative decimal 1, and put the result in register 5. So here you have n-1. Okay. So now we would want to check for the positive, because if it's positive, right, it's going to go back to fab. So as it loops, right, if it continues to loop, it would only continue to loop if it's positive. Okay. And so if it's not positive, as it gets to 0, right, it's going to exit that loop. So that means that I would handle this right here. Okay, I have a chat question. Okay. You too, thank you.
Professor, I have a quick question. If you accidentally put and instead of add, would you clear those 2 registers out on accident?
Yes.
Okay.
Yeah, I gotta be careful with the and the add. I've seen programs that have that problem, right? So yeah, just be careful with. Now, when you and, like, so for example, if I put the and here instead of add, right, it will just and whatever that's in those register and put it on here. So yeah, we want to make sure that we have that the correct way. Okay, so we would keep looping if it's positive, right? But if it's not positive, like when it gets to 0 as it counts down, then it would exit the loop, where it would pick up and go to the next line. So that's why we're going to send it back over here, right, as it is positive, so your loop continues. Okay, so then we need to store out what was in register 4, because remember that was your F, right? So register 4, we need to store that out to F of n. That is an actual label that we fill. So we need to store the result in F of n so we can check. Okay. Then as we used register 2 in our loop previously, we have to clear it again so we can reuse it. Yes, you can use register 6 and 7, but you know, we want to stick with what was used as A or B, so that way it is easier for us to get through the program and not confuse ourselves. Because if you start using other register for the same variable, you're gonna have to track multiple register and it gets confusing. So what I did was I tried to use the same register to fulfill, right, the pseudocode subtask. And so I need to clear register 2 here. Then I need to initialize the 1 for the register 2 to represent the A, because that's your seeding point. Is it starts with the 1 and B starts with the 1. So register 2 now holds a decimal 1. So I do an add R2 with the 1 and store the result on register 2. Again, I clear register 3 because we last used it in the last section. So we want to clear register 3. And then again, I initialize it at 1. So B is equal to 1. Okay. So if you look at the next section, that's what we're doing right now. Okay. To do the A and the B is 1. All right. Then we are going to clear register 5 because we also used register 5 in the last section. And we want to initialize register 5 by adding a 2. So your R5 here has a 2. Okay. So flipping back, this is where your index is going to be as 2. Okay. Any question? Okay. So that takes care of the fab section. Then your fab 2, and you can use any label, of course, whatever is easier for you. We are going to do the next part, which is going to be F is B plus A, right? So our B, if you recall from the last part, and the A is in register 3 and register 2. So we're going to add them together and then put it into register 4 because I wanted to stick with register 4 as F. So that's what I did here. And I want to branch to a negative section now. So it's going to check the value for our 4, right? If it is negative, then it's going to send it to the neg section. So we are going to check for this. Okay, because we just did F is B plus A. So now we're going to enter the next if statement. Okay, if it is negative, we're going to send it to the negative. Now we're going to handle N is I. Okay, and then all the exit and all the other stuff. So then we are going to reassign, right, by doing A is B. So we simply do a copy of the register. So we're going to take our 3, which is our B, right, and then copy it to A, which is register 2, by adding a 0. And then again, we are going to do another copy, but this time we are going to copy the F over to B because we have to move right to continue on our sequence. So we have to do the reassignment for our Fibonacci. So here we're going to copy the register again, but F is B. And we have to represent the index. And so lastly, we have the index as R5, which is RI. And so we want to add the 1 to make it I plus 1 because it's now the next value in your sequence. So it's the index plus 1. Okay. And as it is positive, right, just like what we did with the FAB2, as it is positive, it's going to send it back to the beginning and do it again until it gets to 0 and it's going to exit. So that section is this part right here. Okay. Any question? So as we use the neg label, we have to define what that is. So now I'm going to clear R6. And I have to represent the big N as I. That's what they want, right? That's what we need for the Fibonacci. So our I was in R5 in the last section. So we simply copy that to R6, which is going to be your big N. Okay. And then from there, I can store that out to the big N label. And if you recall up here, right, we did a copy for F is to R3. So we're going to take what's in R3 and store it out to F of N because that's actually F, right? F of N. Okay. Any question? All right. So since we use skip, right, we have to represent the exit part up here. So we are going to do a halt in the skip. And that was part of the pseudocode. Now, then, since you have the labels inside for the store and the load, you need to fill it. Okay. So your data section, you have the small n. We're going to fill it like what they asked. The hex 3100. F of small n is 3101. So we fill it there. The big N, we fill it at 3102. F of big N, we're going to fill it at 3103. And we would end our program. So this is an iterative approach to Fibonacci where we implemented loop and we nest the conditions. But now, unlike just the regular iteration where, you know, we would just loop, we actually dynamically use the storage by reassignment. So that means that, you know, we have to reuse some of the register and copy it over. And if you took my CIS11, we spent a little bit of time on how we would use this compared to recursion, right, in C++. Okay. I spent a week on this in Fibonacci and stuff like that. So, and the way that we look at the problem, as you can see, right, if you write out your pseudocode on what that equation would be and how the program should flow, you can take it piece by piece and implement it, and it seems a lot easier as you do it. And you can say, okay, well, I'm entering the loop here. It's going to keep going until it gets to 0 and it's going to exit out. Once it exits out, what is the next section? So you're going to handle the next piece in your pseudocode and so on. Okay. So now it's not too long of a program. So this is what you would see. Okay. So once you have that, you just click File, Save As. And then you assemble. Okay. Then you are going to take your simulator and you're going to load it. Okay. So once we have it loaded, we can, you can go ahead and run the program. Okay. And then you can jump to the section to see. So X3100. Okay. Now, since we didn't set any value, you are not going to see anything there. So if you simply run the program, you got nothing there. See, it's not. So therefore, what you need to do is you need to tell it what n is. And so you can check f of n. Okay. And if you want to, you also need to tell it what the big N is, so you can check for f of big N. So in our lab, after you run the program, right, you need to specify what your N value is. So let me reload this so you can see. So we're going to reinitialize the machine, put in our program. Okay, then we can set the value, so you can start with the small n. And then let's say that I want the 8th position. Okay. And then let's see, 3102. Okay, there you go. So for the 8th position in your, I think I have, okay, yeah. For the 8th position, for the 8th number in Fibonacci sequence, you have a 15. And you can manually check this by doing addition. Okay. And so you can also test, so for the 17th position, because we're controlling overflow here, right? So when it gets to the next part, you need to have 2 additional locations in the memory to store larger values. And that's what the problem really wanted, was for you to be able to handle, right, what the additional value would be if it's large. Okay, which is your big N. So that means that when you look at the simulator, okay, after 15, when your N is 17, it is this value in hexadecimal. And it traps out there. Okay. So this is why we use 2 additional memory addresses or 2 words to be able to handle the overflow. So it's just the subsequent locations. Any questions? Okay. So this program teaches you on how to, right, implement your conditions, also your for loop. Okay. And because Fibonacci is infinitely going, so we can loop it, right, to the value of n. So whatever, you can get it going forever and ever and ever, or if the user set the value for n, where you set the value, it's going to loop to that. And then when it counts up to that, it's going to exit the loop. So with that, you would implement the for loop. Now, in the case where if you want to use a for loop and you set a value, you set the values. Let's say I wanted to loop it 5 times, right? For a partial sequence, then I need to initialize the n at 5. So that means that somewhere in that loop, you have to get that register that holds n to be a 5. Okay. But since we say that it's n, it would be whatever we set it on the simulator. So it will just loop based on what you set. Okay. Because when you do your project, right, you might have a for loop that would require a certain value, right? It will go up to, it will loop up to, 10 times or a maximum number of time. Then you just have to introduce that value to the register once you allocate that, once you set that register for that n, right? Which is whatever the maximum value you want to loop it to. Okay. So in our case, we would set it afterwards, and then it's just going to check. And when it gets to that value, if it branches to no longer positive, it's going to exit out. Because last week we talked about while, right? Now you would see how the for loop is implemented. And you can also implement the count, and as you do it, you can subtract. And so you've seen that before too. So, okay, any question? All right. So for
Professor, if you wanted us
yeah.
to provide a snapshot, would you want to see the inputs that we put in, or just the code
Yes.
running?
Yes.
Okay.
I want to see values here, right? For your n and your big N, so you can test it with the n value. Okay. And then, so that way we can see that it's working. Okay. And then, so if you go to 3100, and then you can set it to so when you set 3100, that's actually the position of the number in the sequence. So, how many numbers do you want to go down? Okay. So let's say if I wanted to go to the 9th number, I would put the hex 9 there. And then I click OK. So let's say that if I only set, oh, I forgot to load it. And then let's try that again. 3100. Set it at 9. And then let's see. So it tells us that at the 9th value, right, at the 9th number in that sequence, right, this is the result. And then for the overflow, for the big N and that, okay, I didn't set that, so it's going to show the f of n is this. Any question? And you can test it with something that, you can check and try and see. Like any program, you're always going to have a ceiling, so you will reach some limit. And we did try to control overflow. Can this program be better? Sure. There are different ways to approach Fibonacci. And so we can, we can think about how we can use recursion, is there a better way that you can loop this? So normally when you look at a Fibonacci, even in C++, it will look something like this. Okay. This is because we're seeding it at 1. So this is why you would have this part. Okay. Because if you seed it at 0, you have to tell it that if it's less than the first, if it's before the second position, it will just be f is 0. So you have to do the if in that case too. Okay. Any other questions? Okay, so this is generally a simple program to do. Okay. And as we get through this, okay, for next week, when we do the lab for next week, our next week is going to be a little longer, but not too much. Okay, so we are going to do multiplication and division. So, you know, we are going to use modulus for the division, and we're going to handle all the remainder. Okay, so we will work on loop a little bit more, and then we would, you know, see how we can implement multiplication and division in assembly. It seems really simple at the higher level, but at the lower level, you have to, again, right, break it into smaller pieces so you can see. So that's going to be our next lab. And so I'll walk you through that as well. Okay. And then you can, I recommend, again, I'm going to say this, read the chapters, even though, you know, the book was written a while back. It has useful information, stuff about, you know, how you work with instructions and memory and things like that. So as we move along in the chapters, you're going to see that we will correlate a lot of the things in what we would see in C language or C++, because most of you have had classes in C++ so you can see, or programming classes. So it is easier to really understand how you will program in C++ and what the compilers see. So by the end, you would be able to write stack and handle arrays, like how you would in a C program, and implement loops and everything. Okay, whatever you can do in C, you can do in assembly. Now, I was coming to work today and I was thinking about like how my student would think about assembly. And yes, we do a lot of things manually in this class. LC3 is at the very low level, but keep in mind that when you work in assembly, right, for some of the newer languages or even now in the field, you do have libraries and things that you can incorporate, and all you have to do is you can link those library. You need to bring it in and you can introduce it, and we'll talk about how to use the .external to link other files and other libraries to your program, because you don't want to write everything from scratch if there's something that you can use already, right? It's like doing include in C++ or import in Java and Python, right? You can just bring in the library to let it handle some of the things. So now LC3, for the purpose of this class, LC3 is really designed for you to understand like the basics and be able to write a full program in assembly. But, you know, with the additional resources, you can definitely incorporate other elements and things like that in assembly. It's not just doing everything manually. So, you know, the important part with all of this, why I'm spending the time to give you the code and explaining the code to you, is to make sure that you understand line by line what that means, how we solve the problem. And so hopefully with that, you will be able to write your own program for your projects. Okay. Okay. Any question? Yeah, this is only going to be a little bit of time, so work on it. If you have any questions or any concern or anything, just send me an email message or stop by to see me during office hours, either via Zoom or in person, because when I'm here on campus for office hours, I also turn on Zoom, unless, you know, sometimes I'm a little, like a few minutes late into it because I have overlapping meetings, but in general, it'll be, I'm available. Like today, I was here since 12, so. All right, let me go ahead and stop recording.